Okie dokie. Let's see who we got. Okay, so let's do this. I'm going to give you some values we're going to put in the table. I'm only looking at these last two because they make interesting shapes. We're going to do a T-chart kind of first and have you calculate some values, and then we will look at the picture. So I'm not going to worry about the zeros. I'm not going to worry about the max. I'm not going to test you on any of that stuff at this point. So I'm going to give you weird values to put in for your theta. Okay, so I want you to put in a 0. I want you to put in a pi over 12. Why I did the slashy fraction, I don't know. I don't like slashy fractions. A pi over 4. 5 pi over 12. And a pi over 2. Okay. So in Desmos, okay, all you're going to do is we're going to put in... we're going to actually use a different function because I got to get this solved for r to put it in. So I'm going to, how do I undo the square? We're going to square root both sides. We're going to just work with the positive square root this time. So we've got the square root of 16 times sine of 2 theta. Technically, that's multiplication, so I don't have to break it up. What's the square root of 16? So I could use 4 square root of sine 2 theta. So I'm going to be plugging these thetas into that theta there in Desmos. Okay, so let's just do that part, and then we'll look at the graph. Okay, so don't look at the graph yet. Don't cheat and look at the graph yet, okay? Okay. Part of why I chose this unit versus another, because there were a couple of units I could choose from, because there's about 3 topics we haven't covered, was because the graphs look interesting. All right, so we got sine, and I've got 2, and then I'm going to keep changing my theta. So I put 0 in for the first one. So I put the 0 in like that. Then I'm just going to change it. My next one was pi over 12, and I'm going to write down the decimal point. So I'm going to give you like 2 minutes. Get the table filled out, okay? And yeah, get the table filled out, okay? Got another 30 to 45 seconds to make sure you've got all 5 of those values down. Okay, help me out. We're going to write down what the values are. Okay, so what did we get? We got 0 for 0, right? Okay, what did we get for the pi over 12? 2.83. Is that it? Did it go beyond that? 8 what? 8.2. What was after the 2? 8. Okay. All right, what about for pi over 4? 4, nice. Okay, for 5 pi over 12? 2.828. And then what about for pi over 2? It was 0? Oh, interesting. Okay. So I have it on the cheat sheet I have, it says undefined. All right, so one thing that we kind of ignored is typically when we take a square root, don't we usually take a plus minus? So what that would have done to our answer is I went ahead and I put the negative version in. All I did was pop a negative sign in front of my answer. So technically for pi over 12, I have both the positive and negative of that value. Okay, so I'm just going to adjust that in the table and put a plus minus in front of everything. You can't have plus or minus 0. All right. I know that those are kind of weird, awkward numbers to graph. Let's try plotting them, practice that little bit of plotting. And I know that pi over 12 is not one of the spokes we normally have, right? Technically, this spoke right here is pi over 6. So pi over 12 is going to you want to kind of envision it right in there somewhere, right? So let's see. I'm going to be, my first one starts at 0, right? So I've got a dot at 0. And then I've got to go on the pi over 12 spoke, I'm going to go out almost 3. So it'd be like right there. And then on the pi over 4 spoke, I'm going out 4. So that's out here. Okay. And then let's see, 5 pi over 12. I'm not sure where that's at. Let's see. This would be pi over 2, which for over 12 would be 6 pi over 12. Do we agree? Did I pop pi over 4 wrong? I plotted it on 3. Thank you. It's plotted on 4. So you guys are already doing better than me. All right. So 5 pi over 12 has got to be kind of in here, right? This would be our 5 pi over 12. So along there, I've got to go out 3 again. All right. Almost 3. But I also have all of these for negatives, right? Okay. So let's go across and do it all on the, basically I'm going to come across that spoke and pop it off negative, right? So I'm going to pop one here, almost at 3. On this one, I'm going to go to 4. And then on this spoke here, I'm going to go to almost 3. And technically we want to go graph in order, right? So I'm going to start at 0 and I'm going to follow the dots just like we had them. What shape did I just make? It's an infinity. It looks like an infinity symbol, right? So who knew that an infinity symbol had an equation? Okay. It actually has a name. It's called a lemniscate. Yeah, and I might not be pronouncing that right. So that is actually what the actual equation name for an infinity symbol. And it can be in slightly different locations. Let's just, so that you can see it happen, let's put it into Desmos. The nice thing about Desmos is I can put in R squared, okay? In our graphing calculator, because we do have the ability in the Inspires to do polar, we cannot put in R squared. We would have to solve it like we did here. Okay. And that doesn't always work great because of the plus minus thing. Okay. So let's put it in just to see how it worked, just to see what it looks like. Make sure we did it right. So we're going to go R squared equals, it was 16 sine of 2 theta. And you don't have to, but I'm going to convert to my polar graph. Uh-oh, it didn't like it. What does it not like? Polar equations must be linear in R. Let me try switching to polar mode and see if that helps. Nope, didn't like it. Linear in R. I wonder if I put parentheses around this. Sometimes it doesn't like that. Oh, maybe they don't like, oh, you know what? It wants the square root over this. It didn't like the R squared. I'm apparently wrong. Ooh, that's not what we wanted though. Try putting the square root over the top. There we go. Okay. And there's other ways to like move it and transform it if we messed with, let's see what happens when we switch it to cosine. Oh, not cosine, cosine. Huh? So eventually, I think probably once the seniors are gone, we'll probably take a day and just have you kind of play with the polar equations and see what you can come up with. I know Pedro was playing yesterday and came up with some cool looking stuff. So that's why I picked these, because they look cool. All right, we're going to do one more. Let's look at another cool graph. Okay. Because sometimes it's just fun to look at cool graphs. Okay. All right. Let's look at this next one here. I don't want you, so don't cheat and try to just graph the equation, okay? So it says, use a calculator to complete the table below, then graph this, it says spiral. They totally gave it away. R equals e to the theta theta over 4, we call this a logarithmic spiral because the equation may be written as theta equals 4 natural log of r. Okay, so let's try this, okay? Let's just try putting these values. Oh, wait, it says theta. Okay, so we're going to plug into this guy because we've got to try to find r's, okay? So I want you to plug all of these values into this function here. So I'll do the first one with you just to make sure we've all got it the right way in Desmos here. Okay, so I'm going to close out my infinity sign here. All right, and it was e to the... And then my first angle is negative 3 pi divided by 2. And then we've got to divide that by 4. And there's my decimal point. Okay. So I want you to keep replacing this guy here. I know it's not the fastest probably way to do it, but this is the way we're going to do it. So keep replacing that and get all the decimal points. Okay. So I'll give you like 2 minutes to do that. Everybody get those values. Okay. I'm going to show you the numbers I got. Okay, and I totally cheated and used the answer key. So some of them I don't have as many decimal places as we normally keep. Double check, see if we're close. Match. Okay, let's see if we can get it plotted, because that's part of the thing. One thing we've learned is how to plot a polar graph, right? So 3 pi over 2, okay, is technically... Doesn't seem right. Oh, okay. You should let me do... I'm going to go to 0 first. Okay, so I'm going to start here with this guy. Okay. So at 0, I am supposed to be out 1. Everybody good with that? Okay. I'm going to go in the positive direction first, and then I'll come back and do my negatives. Okay. All right. Pi over 2, I know, is this vertical one here, and I'm supposed to be at 1.48, so about 1.5 rings. At pi, I'm at 2.19, so I'm out 2 and just a little bit more. And then at 3 pi over 2, I'm out just beyond 3 rings. Inside, it gets a little trickier, right? So at negative pi over 4, so I'm going to go back a pi over 4, I am out almost 1 ring. Oh, it didn't change colors. Oh, it did. I picked a bad color. Let me go back to blue. So you can kind of see the difference. All right, negative pi over 2 would be here, right? And it's a little bit more in. Negative pi is going to bring it a little bit more in again. And then negative 3 pi over 2 would be back here, and it's a little bit more in again. So hopefully you're seeing that it's getting tinier and tinier, and it's starting here. Use a different color. Starts here, and it loops out like this. So it makes a spiral, which could go in either direction. Okay. We'll look at it on the graph in just a second. There's been a couple times we've put something in and it started as a spiral. All right. So if you notice, as our angle measure goes this way, right? What do the R values go towards? Yeah, they go to 0. Good. And then see how smart you guys are after a year of calculus? As our angle measure goes this way, right? What do our R values go to? They keep getting bigger and bigger and bigger. What are they going to go to?
Infinity.
Yeah, they're going to go to infinity. Okay. In this particular polar graph, is there any symmetry, like a polar axis symmetry or a pi over 2 symmetry or even a pole symmetry?
No.
Yeah, there's no symmetry in this one. All right, really quick, put it in your calculator. See what it looks like. See if we got it right. Okay, or sorry, Desmos is fine. Okay, so I'm going to just cheat off of this. Yeah, go ahead. R equals. I'm going to change my angle up here to theta. There we go. And it keeps going around and around and around. Look at how much I could zoom out, and it keeps going and going and going, right? Isn't that cool? All right. So those are the different types of, we've seen all the different types of polar graphs now.